All right, this video is going to be about 7.2 division properties of exponents. This is our warm-up that we did today in class. And here are our notes. So Module 7, Lesson 2 notes. Okay, so the standard we're focusing on is to generate equivalent algebraic expressions using the properties of exponents. And one of the things I want you to keep in mind is what is a monomial. So a monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. So if you don't remember pre-algebra or what you learned in previous math classes, whole numbers are 0, 1, 2, 3, but they do not include negatives. So a common misconception is that a whole number can be -1 or -2, but no. If you have negative numbers, those are integers and those are not whole numbers. So what this is saying as a monomial is that you only have a monomial if you have a variable or a product of a number and one or more variables with a whole number exponent. So it can't be a negative exponent, it can't be a fraction exponent or a rational exponent. It must be a whole number. If it has a negative, then what happens is it's no longer a monomial. So that's just something to keep in mind before we actually get to our polynomials module, because I do keep throwing that word out there and I want you to understand what it is. So the first rule we're going to learn about today is our quotient of powers. So to divide two powers that have the same base, and yes, they must have the same base, we're going to subtract their exponents. So for example, we have a to the power of m being divided by a to the power of n. So we can simplify that or write that another way by doing m minus n. So our numerator subtracting our denominator's exponent. We do not do anything with the base. The base stays the same. It stays a, okay? Conversely, a to m minus n, so if you see something written or a base written to a power with subtraction, what you can do is you can rewrite that as a fraction as a to the m over a to the n. So just something to keep in mind as we move forward. All right, so in our first example, we need to simplify 4b to the 5th, c to the 7th, being divided by 2b to the power of 2c. So the first thing we're going to do is group our coefficients and our like variables, and then we're going to simplify from there. And as this popped up, I forgot to mention that when we are subtracting, because we're dividing, we're subtracting, it's really important that if we have a negative exponent, when we subtract a negative, let's remember that we are really adding. So we can't forget our integer rules just because we're now dealing with exponents. So just something to keep in mind or add in the column of your notes so that you don't forget. All right, moving back to our example, group coefficients and like variables. So we have 4 over 2. So we're going to list that here in our first parentheses. B to the 5th over b squared. And then c to the 7th over c. So the reason why we're grouping this is so that we can keep everything organized, okay? Now we're going to simplify our coefficients. And well, let's look, 4 divided by 2. Well, that is going to be 2. B to the 5th divided by b squared. Well, according to my quotient of powers property, I need to subtract those exponents. So I'm going to do 5 minus 2. And then c to the 7th over c. Again, I'm going to subtract those exponents. And it's important to keep in mind that if our base or if our variable does not have an exponent listed, what's implied is it's 1. It's an implied 1. So we're going to do 7 minus 1. Now we just simplify. And so we get 2b to the power of 3, c to the power of 6. All right, now we have another one to simplify, which is a little bit more difficult just because there's more variables. So we're going to do the same thing. We're going to group all of our variables together and our coefficient. So we're going to have our 3 over 9, a squared over 1, b to the 9th power over b to the 8th power, c over c, d to the power 4 over d. Now, I need to simplify my fraction first, which means I need to do 3 over 9, and that can simplify to 1/3. Then I have my a squared over 1. Well, there's nothing to be simplified here, okay? I don't have anything in my denominator, and anything divided by 1 is itself, so it's just going to stay a squared. B to the power of 9 divided by b to the 8th is going to be 9 minus 8. Well, 9 minus 8 will be 1, so let's see what we're going to do with that in a second. Our c, well, c divided by c, that should ring a bell. Any number or variable divided by itself is going to be equal to 1. So we'll get to that in a second. And then d to the 4 minus 1, because we're subtracting those exponents. So a squared is already simplified. There's nothing to do there. B to 9 minus 8, that's going to become b to the first power, which we are not going to write that exponent of 1. It's just implied, so it's going to be just the letter b. C to the 0 power is going to be 1. We should remember that from our pre-algebra or other previous math classes. And d to the 4 minus 1 simplifies to be d to the 3rd. Now I'm just going to write them all together. But here's something that might be new to some of you. Yes, you may want to write it as 1 over 3 multiplied by a squared b d to the power of 3. However, the way you're going to see it most often is like this: a squared b d to the power of 3 all over 3. Because here, I basically need to distribute that 1/3, and when I do that, it would simplify to this. So let's get comfortable with writing our final answer as a fraction. And in this case, our 3 remains in our denominator because our larger number with our coefficient was in the denominator. So we're going to end up with a fraction. All right. Checks 1 and 2 you will try on your own, and then check your answers in Canvas. Now we're going to move on to our next rule, which is the power of a quotient. But something I want you to keep in mind is that we always need to assume that the denominator does not equal 0. This is often written in the explanations and prior to you answering the questions. It'll always say assume your denominator does not equal 0, and that's because that would be undefined or an error in your calculator. So power of a quotient. To find the power of a quotient, we are going to find the power of the numerator and find the power of the denominator. So basically, we're distributing the exponent to both the numerator and the denominator. All right, so let's look at our first example. We need to distribute the exponent to each factor. So here we have 5x squared divided by 6. And I'm going to distribute that exponent of 3 to all 3 terms. So to the 5, to the x squared, and to the 6. Then I'm going to simplify. So we're going to use our properties of exponent to simplify each factor. Well, 5 to the power of 3 is 125. X squared to the power of 3 is a power to a power rule, so I'm going to multiply those exponents and get x to the power of 6. And then 6 to the power of 3 is 216. This cannot be simplified further, so it says simplify further if possible. You can always check if a fraction needs to be simplified by typing it into your calculator and doing 125, clicking the ABC button, 216, and hitting equals. If the same fraction remains, then that means that it cannot be simplified any further. So just a little tip to help you with simplifying fractions if you struggle with that. All right, in this particular case, it cannot be simplified. So again, we're just going to leave it alone, and that's our final answer. Okay, moving on to our next and last example. We are again going to group our numbers and then, we're going to distribute our exponent first and then we will group them in our next step. So this exponent of 2 is going to be distributed to every term inside the parentheses. So we're going to get 3 squared, x to the power of 4, all to the power of 2. So we're going to use our power to a power rule. Y to the power of 2, and then in our denominator, 18 squared, x to the power of 2, y to the power of 2, z to the power of 2. Okay, if I simplified all of that, this is what I would get. I would get 9x to the power of 8, y squared, over 324, x to the power of 2, y to the power of 2, z to the power of 2. So now, just like I did in my first example, I'm going to group my like terms in variables. So 9 over 324 are my coefficients. X to the 8 over x to the power of 2. Y to the power of 2 divided by y to the power of 2. And 1 over z to the power of 2. Now, some students may be confused as to why I put 1 in my numerator. Well, here, z squared is in my denominator. I am dividing by z squared, so I have to make sure that I keep it in my denominator, and I just put it over 1, basically as a placeholder. So this x to the 8 minus x, or x to the power of 8 over x squared is going to become x to the power of 6. Y to the power of 2 minus y to the power of 2, that's going to become 1, because that's y to the 0 power, and anything to the 0 power is 1. Or we should know that anything divided by itself is 1. Whichever one you can remember is fine. So we also need to simplify our fraction. So 9 over 324 becomes 1 over 36. This is going to become, or remain, x to the power of 6 over 1. This is just 1 over 1, and this is, again, just 1 over z squared. Now, you may be asking, why did I rewrite these all as fractions? Well, I wrote them all as fractions because all of our numerators need to stay in the numerator, and all of our denominators must remain in the denominator. So if we keep them as fractions, it's easier to multiply across or know where everything belongs. So our x to the power of 6 remains up top in our numerator. And then we have 36z squared in our denominator. And that's our final answer. You will try these checks on your own and check them in Canvas. And once you finish your 7.2 checks, you're going to work on your 7.2 practice. And don't forget your ALEKS for the week, 40 minutes and 13 topics.